but then I'm not quite sure after what we do.
For part B, is it?
Yeah, so B downwards.
Okay, so what do you know about the height when the spear hits the ground?
It'll be 0.
Yes, so how can you use that?
Do we just have to input that into it and solve it?
That's right.
I've got it as a fraction.
Okay. What did you get?
Um, it's 3 plus root 19 over 2,
Okay.
and the negative of 3 minus root 19 over 2.
And press SD for the for those. What do you get?
Um, it'll have to be the positive one.
Yeah. And what is that?
It's 3.8 seconds.
So let's say that's roughly. And what's the second decimal place?
Oh, it's 3.67.
So let's say 3.67 seconds, and this one is we reject the negative time because time can be negative. Okay. How about C?
Um, I'm not quite sure.
It basically means completed square form. That's complete square form.
Okay.
And so you just have to complete the square.
Is that where we have to bring the 4.9 out?
That's right.
Um, I'm not sure what to do with the 14.7.
Um, so if we wrote this, what might help is to write it the normal way of minus 4.9 t squared. So the t squared first, and then the t, and then the 12.25. So if we take out the 4.9, let's take out minus 4.9. And so that becomes minus 14.7 over 4.9.
Yeah.
So
And then,
and then just go from there, do it the normal way.
wait, what happens to the T on the end of the 14.7?
My mistake, sorry, just forgot it.
Oh, Do you have to get rid of the square and the t?
Yeah, you complete the square. So how do you do that?
Do you half whatever is in front of the t?
Yep.
So that's minus 3/2.
Okay.
If we expand the minus 3/2 squared,
We're doing the opposite of expanding it. If you expand it, you'll just go back to what we had before. So when you complete the square, you should get t minus 3/2 squared.
yeah.
And what else?
We've got the 12.25.
Say it again, sorry.
The 12.25.
Yeah, and don't forget that you have to also do minus 3/2 squared.
Oh yeah. Would we then expand out the minus 3/2 squared and the 12?
You would expand the square bracket, so minus 4.9 times the square bracket, and minus 4.9 times that.
Oh, okay.
So how do you do it?
So that's minus 4.9 t.
Yeah, so that bracket is squared, so we can't multiply before we do.
Oh, we need to expand.
So we would just leave it like that.
Yeah. Then it's minus 4.9 times the minus 3/2 squared.
Mm-hmm.
And that's minus 11.025.
I believe it will be positive 11.025 because it's a minus.
Oh yeah, two minuses.
Yeah. So that is, yeah, plus 11.025. What's next?
We would then have the 12.25 on the end. Adding that.
Yeah. What do you get?
Um, 23.275.
You got 23.275, and we also had the minus 4.9 t minus 3/2 squared. So that's what they asked us to do here.
Yeah.
And okay, part D. Oh, I suppose. Hang on. So what is A? What is B? What is C? Just in case.
So A is the 23.275.
Okay.
B is the minus 4.9.
And so I believe it's just 4.9 because they have a minus as well.
Okay. And the C is 3/2.
That's it. And let's just check to make sure. So A is 23.275, B is 4.9, and C is 1.5. Yeah, 3/2. Great. And they put them as positive as well. Okay, part of D.
Are we inputting them numbers in?
Into what?
Oh, wait, I don't know.
So the way you can show it is what is the smallest number you can get from, like, the smallest square number?
Would it be that? The
No. So let's say, like, 3 squared is 9, 2 squared is 4. What's the smallest square number you can get?
1.
So 1 squared is 1. Can you get even smaller?
Oh, would you go then into decimals?
Yeah. Can you go even smaller? Smaller number than 1? Smaller number than a half?
0.1?
Even smaller. Smallest number.
I'm not sure.
Smallest number.
Wait, 0.
So 0, yes. Even smaller would be -1, -2, -3. The difference is -3 squared becomes +9.
Oh, yeah.
So a quadratic bounces back. And so, yeah, the smallest square number is 0. And so the smallest... do you know at what time would this become 0?
I'm not quite sure.
It would be at 1.5 seconds when t is 1.5 or 3/2.
Oh, when they equal both to 0.
Yeah, so that's when it becomes 0. And so if this bracket was 0, what would the whole thing be equal to?
Just 23.275.
Correct. So 23.275. And then so that's a way to show it. And then if you go back to your calculator, remember when you when you solved it for part B?
Yeah.
So just keep pressing equals and see if it tells you the max at the end, the maximum. So put part B back into your calculator if you changed it, and it should tell you the maximum.
This one just says, yeah, 23.275.
That's it. And I believe the x was 1.5 or 3/2, and that's because that's the time.
Yeah.
Because that's the time when it happens. So in this case, x is t. So at 1.5 seconds, you get the maximum of 23.275. Great. Any questions about any part of that?
No.
Okay. And is this the type of thing you were talking about?
Yeah.
Okay. Yeah. So so it's basically applied quadratics. So all of the stuff that you do that's called modeling is just applying it to the real world. So real world quadratics, they throw a spear, and if you were to, like, track its pattern, it would make a quadratic graph. And so they kind of found an equation that kind of gives you the height of the sphere after a given time, and you can use that. So 12.25 is just like the initial height of the tower, like where it starts up. What is that? The tower is 12.25 tall.
Yeah.
After how many seconds does it hit the ground? So for that one, height is 0. Solve for the time. Reject the negative. The third one is the tricky one. The completing the square, because there's decimals and stuff. But even if you can't do part C, just use your calculator to do part D to find the maximum.
Okay.
Okay, exam question. Let's try it.
So the 200 would be the smallest height of the cables above water level.
Yep. Part B.
Are we putting 346 into the equation where height is,
Correct.
and then solve it?
Correct.
So in the equation where the 200 is, I'll be minusing 346 from that.
That's right.
So that's a minus 146. If we solve that.
That's it.
So it gives it as a decimal.
Okay.
1103.026.
Okay.
And then the negative of that.
Use the model to find the two values, or the negative of that. Two values of x. Okay. Or x equals negative 103. And that's what they asked for, two values of x. And C.
Is this the same as the maximum and the minimum?
No. Totally different. And you might need the diagram for it. The towers at each end are that tall. Use that to find the length of the bridge.
Okay. Are we solving it for when the height is?
Nope.
I'm not quite sure.
So you've got 0 in the middle. We had to find, well, part C told us that the towers at each end are 346 high.
Yeah.
So that there has a height of 346. And, oops. So
Yeah.
this is why we got two answers. One was here, one was here. So this is, where is it? 1103, and this one is negative 1103. And you have to use that to find the length of the bridge.
Oh, are we just doubling
Yep.
from each end? So it's just 2,206 meters.
Well done. And you can see it was a 1-mark question, so it was always going to be something simple, but it just involved interpreting it in kind of real life. Yeah, so we got two answers for the first one because that was the two of them there. It's symmetrical with the origin in the middle. 346 meters high is from here to here. And then part C told us that that is each end. So it's not somewhere in the middle or something. And so we had to just double it to get the total length. It's just about understanding it.
Yeah.
Any questions about that?
No.
Okay. This one. Yeah, it's very similar to what we did. Hang on. Use the model to find two speeds. That's very similar. Find the speed at which the cars the greatest fuel. Okay, use one of those kinds. Part D is a good one. Let's two speeds. Let me just see something here. Let's start from part B, I think. Yeah.
Okay. Is this what we did before with the
so it's
completing the square?
Yeah, so it's very similar. Oops, how did I do that?
When solving it,
I was just messing around. I was just messing around with the calculator. So for part B, you just have to complete the square.
right? Okay. So we're bringing the.
Actually, I just had a great idea. Maybe it's not so great. Go on. Go about your completing the square.
Okay. So.
How are you getting on there?
So I've got it to bring in the x out to the side. So it's negative 0.01, then the square bracket, then a number bracket x minus 97 over 2. And that's squared. And then
so I've just found a way that's so easy that it's worth doing it the other way. So do you remember we put this into a calculator for the previous one?
Yeah.
And so we put it in, we got our two answers, and when you pressed equals again, the maximum t, it gives you the 1.5, which goes in the bracket.
Yeah.
And it gives you the maximum height, which was the 23.275. So
Yeah.
So put this one into your calculator and try it.
So yeah, the x is 97 over 2.
And so where does that go?
Inside of the bracket. So that 97 over 2 is the c.
Yeah. So that's 97 over 2.
And y is 39.5225.
Was it 39.765625?
I think mine was slightly different.
See, I just took it out. So minus 0. Oh, where's it gone? Minus 0.01. 0.975.
I've missed a 5 out of the x one.
Okay.
Right, so the x value is 195 over 4.
Yeah. And the y?
That is 2,545 over 64, which is 39.7. Yeah.
Yeah. Whichever way you want to do it. So I think you'll agree that's a much easier way. So you got the minus 0.01 factorized out. So before we forget this one, hang on. So that's exam. Let me just see these. That's okay. Let's try. Oh, did they make this trickier? So let's try question 4, part B. It looks similar, like it's completing the square, but it looks like we'll have to construct the equation ourselves or something. So we better do part A as well.
Okay.
Oh no, we can. It looks like we can skip straight to part B. Oh, I don't know. No,
Yeah, because it's given it as
we'll just
r equals p.
Yeah. Find the value. Oh, we were supposed to find the value of m.
The value of m.
Yeah, we better find the value of m then. We better do part A.
Okay. Are we using for T 10,000 and for P £30?
Yeah, we can sub in two known values, yeah. 25.
So M's 40,000.
M is 40,000, okay. And then we'll use that for part B.
So from the given equation of R equals P bracket M minus 1,000P, are we putting the 40,000 where M is?
Yeah.
And obviously, are we timesing back out the P?
Yep.
So we'll have a minus 1,000P squared plus 40,000P. And we're solving it before in the calculator to find the maximum and the minimum.
That's it.
So X equals 20. So that's C. Y is the 40,000. Or is it 400,000?
It looks like
400,000.
Yeah.
Yeah.
And what letter
So
is that?
that's A. And the B is 1,000.
B is 1,000. Yes. And I suppose it wouldn't hurt to write it in the form. Minus 1,000. And that was P minus 20 squared. Yes, there we go. Great. And so, part C.
Are we trying to find it from the answers we've just found?
Yep.
Is it the 20?
Yes, well done. £20 per ticket. So before then, they would make less money because they're cheaper, but the demand would be just as high. After that,
Yeah.
although they'd be more expensive, demand would start dropping off. So it's like that, you know. Then it start dropping off, the more expensive it gets. Great. Any questions there?
No.
Okay, so let's now go back. So we did this one. So it's yeah. So they made us do a little bit of work, but then we could use our calculator for the other stuff. Okay, part C for this one.
Is it the answer from C?
And what is that?
So it'd be 48.75.
Correct. 48.75 miles per hour. And D.
Are we inputting 120 where X is?
Correct.
I got -11.
So that is equal to -11. Comment on the validity of using this model for very high speeds.
That's not very valid, is it? Because it's gone to the minus.
Correct. The model is invalid. It gives negative results, which are impossible. You can't drive, -1 miles.
Yeah.
Any questions there?
No.
Okay. And negative miles. That was great, great, great. So I just want to see if this one is any different. Okay. Yeah, it's a bit trickier. Okay, let's try this.
Right. Is it just 6 tons for A?
Amount of fertilizer used affects the grain. Well, how much grain would each hectare yield without any fertilizer? Yep, 6. Six kilos per hectare. B.
Are we supposed to input the 20 into the equation to see what his yield is?
Yeah,
Already.
For G or F?
The 24 F.
That's it.
I got 6.5976.
I got 6.576. Is that what you got?
Yeah.
Let's see. Is that the answer they were looking for?
No, because he wants to increase it
Mm-hmm.
by 1 ton.
Mm-hmm.
So if we add 1 to that
Mm-hmm.
to make it 7.56.
7.576.
Yeah. Oh yeah. And then make that equal to the original function.
Brilliant.
Then make that equal to 0 and then solve it.
Great.
I got x to equal 47.94.
I'm getting a different number.
Wait. I think I might have put the 6 minus 7.575 wrong.
Okay.
Um, I've got 440.35.
Mm-hmm.
59.65.
Great. Okay. Yeah. So that was a tricky one. 4 marker. So you had to figure out first sub it in, then add 1, then solve. So you had to do a bit of everything with that one. Any questions there?
No.
And so those are the exam questions for that. I have the other exam questions. I want to see if they're any different. So this one, a ball is kicked. So this is more like the ones you were talking about. Well, we've done harder ones since then. Find the horizontal. Just kick to a point where it lands on the playing field again. So how would you find when this ball, where it lands?
Will we be finding it for x?
Yeah. So it starts at 0, it's kicked, and it falls back down here. And so how would you find the distance that it travelled?
Will it just be when x equals to 0?
When x is 0, y is 0. So that would be here.
Oh, will we solve it?
Yeah, and how would you solve it?
By completing the square.
Is there an easier way? Completing the square would be a good way to find its maximum height. We want to find its distance, so like the position when it hits the ground again.
That would be like the intervals.
And how would you get that?
Should we just factorize it?
Basically, yeah. You would solve it by making y equal to 0. And it's because at the beginning the height is 0, and then at the end the height is 0 again. So if you make y 0 and solve it, you'll get 0, and the second answer will be the distance it's traveled.
Okay.
And then the second part is completing the square. Easy way is to just use a calculator and then use your answer to get those two values. And you can just use a calculator for that. Showed at this model, so that's completing the square. You can use a calculator, hence or otherwise. The maximum, yes, that's fine. The coordinates of the point A. How would you find the coordinates of the point A for this one?
We'd just be finding the maximum, or that would be the minimum.
Yes, and hence find an equation. Okay, it's actually, that might be worth looking at. Let's see this one. Does not contain a constant term. Using model. Workers supplied. Produced per day. What would be part A for question 4?
Is it because if there was no workers, there'd be no cars made?
Correct. Let's see. A ball is thrown on top of a cliff. Yeah, that's okay, I think. Justification, that's okay. Just making sure we've covered everything. This model is not valid for self because the race is negative. How about part A for this one?
Would it be because there is no profit, or is that what Ellie's trying to say?
You're correct. So it's quite a strange one. Yeah, basically, she's incorrect because there would be no profit. It would be a loss.
Yeah.
So for some things, you can't get a negative, but for revenue, yeah, you can get a loss. You can get profit, you can get loss.
Yeah.
And it's just completing the square, and then it's about maximum. And then that's it. Okay, and I just wanted to see question 3 was a bit strange. This one strikes me as strange. Let's try this one. Question 3. Yeah.
So for this, are we creating a quadratic equation?
I think we have to, yeah.
Um. So we know the the x-intercepts
Mm-hmm.
and the y-intercept.
Mm-hmm. So it goes through 0, 0.
And the x-intercepts are 0 and 2.5.
Mm-hmm.
Are we forming the equation from them?
Well, part 1 was just write down the coordinates of the point A.
So if it'll be 1.25 and then minus 3.
Mm-hmm.
So the equation, so we can use that for the minimum.
Mm-hmm.
Uh, I'm not sure what to do with them. It'd be inputting the coordinates of A.
Yeah. So A, if we were to put it in completed square form, it'd be like minus 3, and let's say plus, well, let's say as minus b x minus 1.25. Remember we were doing,
Yeah.
so that's one way of looking at it. And then the other way is with this brackets. So as a quadratic, if it goes through 0, 0, then you have x and x minus 2.5, something like that.
Yeah.
But I think, so 2.5 is the same as 5 over 2. So I think that would be 5x minus 2. I think it's just this second one, and we could just expand it and see if that works.
Okay.
If that could, oh no, hang on, it's a negative one, so it should be negative x on the outside. I think that's it. And if you wanted to, you could use simultaneous equations to find it, but
Okay.
I think that'll work. Yeah, so what would you, so that's probably kind of a special one. I just thought we'd take a look at that. Yeah, so how was that for you, Eva?
That was good.
Great. And so is there any topic in particular you want to do for next time? Do you know?
I wanted to look at modulus functions, but graph translations of them.
Okay, so Eva. So yes, and I'll just do like transformations in general, is it?
Yeah.
Of mod graphs, because they can be reflected, they can be stretched. So transformations of mod graphs, yeah.
Yeah.
Mod function graphs. Yes. Any questions for me in general?
No.
All right. Well done, Eva. You did great. I look forward to chatting again next week.
Thank you.
All right. Have a good week. Goodbye.
Bye.
Bye.